ABCD is a rectangle of dimension 6 into 8. So ABCD is A B C D is a rectangle with dimension 6 and 8. These are the dimension of the rectangle. Excuse me. ABCD is a rectangle of dimension 6 and 8. DE and BF are the perpendiculars drawn on the diagonal of the rectangle. DE and BF are the perpendiculars drawn on the diagonal of the rectangle. What is the ratio of shaded region to that of unshaded region? I am shading red region is the shaded region and unshaded region is these two. Now we can see here that the shaded region, both of them are exactly symmetrical, and unshaded region, both of them are exactly symmetrical. So what we can do, if we can take the ratio of one shaded region is to one unshaded region, will get the ratio, because it's a ratio. If we sum up both the shaded region which are identical and both the unshaded region which are also identical, will get the ratio same time, because it will be becoming 2 times of shaded and 2 times of unshaded. So ultimately what we want to get the ratio is delta 1 upon delta 2. That is all what we want to do. We want to get this I am saying delta 1 and the red area is delta 2. So we can get the, if we can get delta 1 upon delta 2, total unshaded will be twice of delta 1 and total shaded will be twice of delta 2. So rather than this, let's fair enough calculate the ratio of delta 1 is to delta 2. That will be the ratio of shaded is to unshaded, because both of them are symmetrical, and which is also equal to twice of delta 1, which is also equal to twice of delta 2. It's one and the same thing. So we need to evaluate ratio of delta 1 and delta 2. Now what we can do is, we know area of a triangle. Say I take triangle ADC, half base into height. Base for the triangle, this is 6 we have, this is 8 we have. So hypotenuse AC will be equal to 6 square plus 8 square root over that, which will be equal to 10. There is no denying the fact that it is 6, this is 6, this is 8, and so hypotenuse AC will surely come out to be 10. So this complete AC should be equal to 10. There is no denying the fact. AC will come out to be 10. Diagonal will be sum of squares of two sides. AC is 10. Area of triangle is half base. Base is AC and height is DE. Area of triangle ADC is base. Base is 10, base is AC and height is DE. Height is DE. Half 10 into DE is area of triangle ADC. Base is 10 into height is DE, which is also equal to, there is one more way of evaluating the area of triangle ADC. This is right angled over here. So this is base and height. One more way, half base into height from here. So we can surely say that should be equal to half 6 into 8. I hope the point is being understood. This is base, area of triangle ADC, this is base and here is height. Half base into height is the area. Half base into height is the area, and half base for right angle over here, half base into height is the area. So one thing to be sure about, value of DE is to be equal to half goes away, 10D is equal to 48. 4.8 is the value of DE. DE is 4.8. This side will come out to be 4.8. Let's open it more here. This side is DE. DE is coming out to be 4.8. This is 4.8. This is AC and this is 6. So if this is what we can get. Basically it's a multiple of a triplet. If we see this value DE, this is, I'm drawing it again, DE is 4.8, which is going to be 1.2 into 4, and here it is 6, is DA is 6, which is going to be 1. So it's basically what, 4, this is 5, so this have to be 1.2 into 3. I hope 3, 4, 5 is a basic triplet, and everything inside the triangle is going to be a manifestation of this basic triplet. What we are getting, this is 3 into 2 is 6, this is 4 into 2 is 8, so this side will be 5 into 2, so this is coming out to be, and the basic triplet was obviously 3, 4 and 5. Let's see how beautifully he is utilizing the triplet. And inside it also, this 4.8 is going to be 1.2 into 4, this is 3, this is 4, so this have to be 5. So this was 1.2 into 5, 1.2 into 4, this have to be 1.2 into 3, that is equal to 3.6. or other way around also we can calculate the hypotenuse by Pythagoras. If you are not able to understand the triplet, that is not a problem. We can get hypotenuse as we can get the base as hypotenuse is square minus perpendicular is square. We can get this value as 3.6, and we know the complete side is going to be 10. So if it is 3.6, it have to be 6.4. So we have base for this triangle as 3.6, and here we have base as 6.4, and we need to evaluate what was our purpose. We need to evaluate delta 1 unshaded region, and red region is delta 2. So we are through with the question, because we know area of delta 1 is half base, its base is going to be 3.6 into height I can say DE, and that is delta 2. If we take the shaded region, red shaded region, that is equal to half, base is 6.4 into DE, height is same for both the triangle. So we have, and the vertex is same, so the height will also come out to be same. Ratio of area will be ratio of bases only, because the vertex is same, so the height will be also same. The basic ratio is 3.6 is to 6.4, but the question is asking shaded upon unshaded. So rather than, the question is asking basically delta 2 upon delta 1, rather than delta 1 upon delta 2, the question is asking shaded upon unshaded. Very sorry, the question is asking shaded upon unshaded. So if we want to calculate delta 2 upon delta 1, that should be equal to delta 2 upon delta 1 is equal to 3.6 in the denominator and 6.4 in the numerator. This is the ratio for delta 1 is to delta 2. Now we have to look among the options. 6.4 is to, which is equal to, if we take, this is 64 upon 36, which is eventually equal to 16 upon 9. We can cancel by 4. So the option, I was looking for the option among the options which value satisfies it. So it is 16 upon 9 is the ratio, which is option B, which was only the ratio of these two sides. And once we can get this, we can also, because their height is same, delta 1 upon delta 2, and shaded we can do twice of red, and this we can do twice of blue, which is not required. So delta 1 upon delta 2 will be equal to 16 ratio